So this is the free Desmos graphing calculator. If you haven't used it yet, I recommend you give it a shot, desmos.com/calculator. You can put graphs, equations, type them in, and then your graph will be made for you automatically on the right side. You can create an account, sign in, and save your progress. But I just want to show you some examples of some of the transformations that we've seen in lesson 5.1. So in 5.1 we had made some transformations about the y is equal to x squared function. So a parabola like this, where we have the vertex being 0, 0, and you can see all the different points along the way. And so what we want to do is transform this, and we saw that one way you could transform it is by modifying the a value that's in the front here. Right now the a value is 1, but if you put an a value that's more than 1, you'll notice something interesting happen. So let's say I put y is equal to 2x squared. You'll notice this green one here, being y is equal to 2x squared, still has the same vertex as y is equal to x squared. It's just that it seems to be narrower, narrower than the y is equal to x squared parabola. And we'll do that again. We'll add another one. This time we'll increase the coefficient even more. We'll increase that even more. We'll do, let's do 3x squared. And you'll notice the purple one here, still the same vertex, but even narrower. So it gets even narrower, and that's because it's stretched vertically from the vertex. And we'll do one more. Let's do y is equal to 5x squared. Oops, 5x squared. And you'll see again that this one's even narrower than the previous one, even narrower than the previous one that we had before. So as you increase the value of a, if a is larger than 1 and is positive, the parabola gets stretched vertically, has the same vertex as x squared, but gets stretched vertically. And that's because things start to rise faster. It makes sense. The y value is multiplied by whatever that coefficient is. So in this case here, we multiply the y value by 2, then here by 3, then here by 5. So it rises faster. That's why it's narrower, because it's going up faster. It's being stretched upwards. Let's say that that coefficient, the a value, was less than 1, still positive but less than 1. So for example, let's make it 0.75x squared. So notice now that we have 0.75x squared. I'm going to remove this, this, and this. 0.57x squared is a little bit wider than x squared. And that's because it's rising more slowly. It's 0.75 times x squared, which means that we're getting smaller increments for every movement that we make on the x value. Let's do that again with another decimal. Let's do 0.5x squared, less than 1. Notice we're even wider. So the closer we get, the smaller our decimal value becomes here, the wider parabola becomes, because we're rising more slowly. So for example, let's do something crazy here. Let's do 0.025. Oops, 0.025x squared. Look how wide that parabola is, because it's rising so slowly. So if you have an a that's less than 1 but still positive, then what you end up getting is a wider parabola, because it's been compressed compared to the x squared instead of stretched. So those are some transformations that we saw. Another transformation we saw is a reflection. So here we have y is equal to x squared. If we have y is equal to negative x squared, you'll notice that the parabolas look very similar to each other, except when we add that negative in the front there, as our a, when we have a negative a, it causes a reflection, a mirror image of our original parabola. And so we have our mirror image over here. It's a rotation about this axis here, which is the x-axis. The x-axis is acting like our mirror. Let's do another example here. Let's do y is equal to negative 3, or y is equal to 3x squared. Let's do that again. So 3x squared, this one over here. Now if we also apply a reflection transformation to it, negative 3x squared, you'll notice we get the reflection of this negative 3x squared right over here is negative 3x squared. So if you had a point over here, if the y over here was positive, when you apply that negative in the front, that y is now negative. If you had a y over here that was positive, when you apply the negative in the front, that y becomes negative now. So everything is kind of flipped for every x value. So if the x value was positive, if the x value had a positive value of y here, then the x value, once you had the negative in the front, will now have a negative value of y here. And so that's called a reflection. So what we've seen in this one here is an example of reflection occurring and also vertical stretching. You could have a reflection and a compression at the same time. So for example, if we saw y is equal to 0.5 x squared, we have a compression happening. But if I want to apply also reflection, I could do minus 0.5 x squared. And notice that my compressed, wider graph was flipped, reflected about the x-axis over here. Same vertex still, just compressed because it decreases more slowly in this case. I say decreases more slowly because we're going down in this case here for every value of x that we go up. Okay, it depends on which way you're describing the parabola. And so you can use Desmos to practice the transformations to make sure you verify your work and that you're on the right path when you're graphing by hand. I wouldn't rely on Desmos to do all your graphs, otherwise you'd lose that ability. So please make sure you use this really to verify and just to test any maybe hypotheses you might have to see that you're on the right path. And so that's how you use Desmos for some transformations. We've applied this to lesson 5.1, transformations involving reflecting, stretching, and compression of graphs, specifically of y is equal to x squared.